Hey everyone! So if you're working your way through AP Physics 1, you've seen a million of these velocity time graphs. But there's this one really common trap that's so easy to fall into. Today, we're going to clear all that up and show you exactly how to find acceleration the right way. Let's dive in. Okay, so you get a graph just like this on a test. You see that line going up, so you know the velocity is changing. And if velocity is changing, you know there's got to be some acceleration happening. The big question is, how do you actually pull that number out of the graph? What's the right move here? So before we jump into the right answer, we have to talk about the wrong one. And we're doing this first because it's a mistake that is just so tempting to make. We're going to tackle this thing head on. I mean, you see it, right? There's that nice, neat shape right under the line, a perfect little triangle or rectangle, and your first instinct is to just calculate the area. It feels like the most obvious thing to do. But trust me, when you're looking for acceleration, that path is a total dead end. So what is that area actually telling you? Well, it's not useless information, not at all. It's just the answer to a completely different question. The area under a velocity time graph tells you the object's displacement, basically how far it's moved. Super important if you need distance, but it is absolutely 100% not acceleration. Okay, so if the area is the wrong way to go, what's the right way? Well, the answer isn't under the line. It's actually hidden in the line itself. This is that aha moment you've been waiting for. You should think of this graph as kind of like a multi-tool. It gives you two really important pieces of information. We've already figured out that one of the tools, the area, tells you all about displacement. But the other tool, the steepness of the line, its slope, tells you something else entirely. And yep, it's exactly what we're looking for. Let's just hit pause and go back to basics for 1 second. What even is acceleration? At its core, it's just the rate of change of velocity. The formula says it all, right? Acceleration is the change in velocity, that's our buddy delta v, divided by the change in time, delta t. Just keep that formula right in the front of your mind. Now, let's think all the way back to math class. How do you find the slope of a line? It's rise over run, right? The change on the vertical axis divided by the change on the horizontal. Okay, now look at our graph. What's on our vertical axis? Velocity. Our rise is a change in velocity. And the horizontal axis? Time. Our run is a change in time. Wait a second. Rise over run here is just delta v over delta t. That is the exact same formula. And that brings us to the single biggest takeaway of this whole thing. You ready? On a velocity time graph, the slope is the acceleration. They are literally the same thing. It's not a trick, it's not a weird rule, it's the definition. Once you really get that connection, you'll never fall for that area trap ever again. All right, knowing the theory is one thing, but let's actually make it real. Let's get our hands dirty and actually calculate the slope for an example. It's a really simple four-step process. First, just pick any 2 points on the line that are easy to read. Second, figure out the rise. That's the vertical change in velocity between them. Third, find the run, the horizontal change in time. And finally, you just divide the rise by the run. That's it. So let's say we pick our 2 points. We see the velocity went up by 8 meters per second. That's our rise. And it took 2 seconds for that change to happen. That's our run. We've got our two numbers. Simple as that. And now for the final step, the division. 8 meters per second divided by 2 seconds. That gives us 4. But check out what happens to the units. We have meters per second. That simplifies down to meters per second squared, which is the exact unit for acceleration. See? It all just fits together perfectly. And the slope tells you more than just a number. It actually tells a story. A positive slope, like the one we just calculated, means you've got positive acceleration. The object is speeding up. If the line is flat and horizontal, the slope is 0, which means 0 acceleration. The object's just cruising at a constant velocity. And a negative, downward slope? Well, that's negative acceleration. The object's slowing down. Okay, so let's just zoom out for a second and put these two powerful tools, the slope and the area, right next to each other, just to make sure this distinction is absolutely crystal clear. So here it is. This is basically your cheat sheet for any velocity time graph you'll ever see. Just remember, the slope of the line gives you acceleration. The area under the line gives you displacement. They are two different features of the graph that represent two totally different things in the real world. Do not get them mixed up.
So, we've pretty much mastered that a straight line on one of these graphs means constant acceleration. But that leaves us with a really interesting final question, doesn't it? What if the line isn't straight? What does a changing, curved slope tell us about how that object is moving? Something to think about. Thanks so much for watching.